reverted compound gear trains. And in this one here, I want the input shaft to line up or be coaxial with the output shaft. All right, so not only do you want to have the precise gear train value, but you also want to have the input shaft and the output shaft be on the same axis so that they are, well, they line up. So let me just do an example. By example, I'll show you what I mean. This is 915, page 533, reverted compound gear train, where you're trying to achieve a 40-to-1 ratio, so you know you need to use compound gears. And the diametral pitch is 8 teeth per inch. Okay. So on this, I'm going to write that not only does N2 over N3 times N4 over N5 have to equal 1 over 40, but R2 plus R3 has to equal R4 plus R5 to have input and output shafts coaxial, which means that N2 plus N3 has to equal N4 plus N5. So does everyone see what we're trying to do here? We're trying to get the input shaft and the output shaft lined up. And what that does for us is it creates, so this right here, if I look at this has to be a whole number, an integer value. And so what this does here, if we look at our gearbox, we'll have your input shaft here, an output shaft here, and these things here will be lined up. Now the nice thing, or the reason why you want to have this happen, is normally you have your motor and your output over here, and generally they're on the same axis. So in order to achieve a coupling between your motor and whatever you're driving, ultimately driving, it would be nice if the input shaft and the output shaft of your gearbox are lined up. And just place it in the middle there. The other thing about having the input shaft and the output shaft lined up is that there's no moment on the gearbox. It's purely in compression or tension, and there's no moment, so there's less shaking going on there, right? Or less likelihood that things are going to be off balance. Okay, so on this we have so let's just write down the different ways of doing this. So we have 40. So to do the least factors approach is 2 times 2 times 2 times 5. Okay, so that's one way of doing it. And that means that I can go with, and what I want to do is, you really don't want to go with a 4-to-1 and a 10-to-1 because those ratios are so different. You want to have something a little closer. So an 8-to-1 and a 5-to-1 is pretty close. And so that's the ones that you're going to use, because that will generally produce a more compact assembly of gears. So I'm going to go with 8 to 1 and 5 to 1. So with this here, 8 to 1, I have to have 17 teeth minimum. All right, so let's just call that N2 minimum. And with a 5 to 1, I could actually go with 16 teeth. So my N4 minimum could be 16 teeth. Okay, again, we're just using that table 9-5A. Let me set N2 over N3 equal to 1 over 8. That means that N3 equals 8 times N2. I also have to have N2 plus N3 equal this constant K, because I'm trying to get it to revert. So that means that I have N2 plus 8 times N2 equals 9 times N2, which equals K. So let me just stop there for a second to make sure people understand what I'm doing. So my ratio is N2 over N3 is 1 over 8. If I say N3 equals 8 times N2, I get that. But I also want it to revert, so I have to add N2 plus N3. Well, N3 is defined in terms of N2 by saying it's 8N2. So N2 plus 8N2 equals 9N2, which equals that constant K that I'm looking for, that I defined right here. All right, so that's what I'm doing. Again, it's to, you're doing this right here in order for the thing to revert, so the input shaft and the output shaft are coaxial. So then on the next one, I have N4 over N5 equals 1 over 5, which means that N5 equals 5 times N4, which means that N4 plus N5, which equals K, implies that I have N4 plus 5N4 equals 6N4, which equals K. All right. All right, so let's look at different cases. So case 1. N2 minimum equals 17 teeth, and I'm saying that 9 times N2 equals K. That means K is going to equal 153. All right. So then, if K equals 153, I know that 6 times N4 equals K. Yeah. If K is 153 from here, in the first set, 6 times N4 equals 153, which implies that N4 equals 25.5. Well, we can't have that. So I'll have to look at something else. So that's case 1. So case 2,
Can you explain again why it's not right? I have 25 feet.
Because you can't have a gear that just has a half a tooth count on it.
Oh,
Okay, right? So on this one here, if I do N4 minimum equals 16 teeth, that means that 6 times N4 equals K, which equals 96. So if K equals 96, that means that 9N2 equals 96, which means that N2 equals 10.6. Again, we got a fractional tooth count. So this is bad on two fronts. So the fractional tooth count and also N2 is less than 17 teeth. So it fails on two fronts here. Okay? Because N2 has to be at least 17 teeth or bigger. All right? So let's keep on working this thing. So case 3, let's take N2 minimum. Now that's a minimum, but I can pop it up to the next number if I want, 18 teeth. Okay? Which means that 9N2 equals K, which equals 162. If K equals 162, then I have 6 and 4 equal 162. And when I do the math on that, I have N4 equals 27 teeth. So this right here so that works. Now, you may ask, well, how do we know which way to go? You just have to work this thing. All right? You have to look at it different ways, increase these numbers, see if you get something that works. All right? So your solution to this one here is N2 equals 18 teeth, N3 equals 144 teeth, N4 equals 27 teeth, N5 equals 135 teeth. Now, on this right here, this is because we have this is the 8-to-1 ratio going on here, and this one here is the 5-to-1 ratio going on. So that's where we get N3 and N5 respectively. All right. So I want you to, now remember the diametral pitch here was equal to 8 teeth per inch, I think, yeah. So D2 equals 2.25 inches. D3 equals 18 inches. D4 equals 3.375 inches. D5 equals 16.875 inches. So note that N2 plus N3 equals N4 plus N5. And D2 plus D3 equals B4 plus B5. So that means, therefore, reverts. Meaning that the input shaft and the output shafts are away. So let's do another one. So that was the least factors approach. We took 40 and broke it down into its least factors. All right. So let me finish up by just looking at this one here. And I'll just start this one here and then we'll finish it later. So case B would be looking at the square root approach, which is 40. So that equals 6.32. So I'll round down on this to get 6. And that means I'm going to go with a 6 to 1 and a 6.6 to 1. Now, again, this worries me a little bit, but I know that any factor times 3 will get rid of that 6 2/3. So I'm not so concerned about it. Okay? So what we'll do is, let's just set up this at least, then we'll end. So 6 to 1 means that N2 min is going to equal 16 teeth, and the 6.6 to 1 means that N4 min will equal 17 teeth. So next time what we'll do is we'll work this all the way through and see what type of answer